Okay. And I'm going to go ahead and share my screen. Okay, just as a reminder, everyone who's on Zoom, please interrupt me as I go. It's really hard for me to track questions in Slack while I'm lecturing. So if you're on Zoom, please interrupt me. For those of you who are here, please feel free to just shout out questions as well, or raise your hands or whatever. We have a few people trickling in, so I'm actually going to pause and let everyone take seats. Okay, so this lecture is on Docker, and we're going to be starting from the ground up. My assumption, for the most part, is that some of you may have used Docker. Actually, can I get a show of hands of how many people have ever used Docker before? Oh, wow. Okay, that's a lot more than I expected. Online participants. Oh, yeah, great. Okay, that's good. So usually my expectation is that Docker is one of the newer tools we teach, but I'm glad to see you've all used it before. So this is one of the few lectures where we can't do things in the hub. Docker, in fact, is part of what makes the hub, the Jupyter Hub, work. But because of that, or partly because of that, we can't run this lesson in the hub. So I'm going to be doing a lot of live coding during this lesson, but I'm going to be doing it in my own terminal. And in order to follow along, you'll need to have your terminal open, and you'll also have to have Docker installed. So if you haven't installed Docker yet, I posted the link in the channel for this this lecture. It's basically docs.docker.com/get-docker. You can install Docker here. If you haven't installed it yet and you want to follow along, hurry. You've got probably 5-10 minutes before I start actually using the command line. Additionally, you'll need a shell. So if you're running on Linux or Mac, you should already have a shell installed. And if you're on Linux or on Mac, in fact, you can go up to your little search icon and search for terminal and run that, and that'll open up your shell on your local computer. If you're on Windows, I posted some instructions on how to install a shell, but you'll need to follow those instructions. Unfortunately, I can't help you very much with Windows. If you're on Linux, I'm assuming you already know how to open a shell. Okay, so for anyone who needs to install this, you should go here and go ahead. Additionally, I'm going to post a version of this lesson in the channel as well. So that's this page right here that I'm looking at right now. This is another of the software carpentry lessons. This is not actually part of the official software carpentry lesson plan. This is what's called an incubator lesson, meaning people are currently working on it. So you can go to this website at this lesson at the website I posted in the Slack channel. But I don't recommend following along on this website today. I'm going to deviate from it a bit. This is more so you can come back and review later if you were interested. Okay. Additionally, if you're running on Mac, then you need to make sure that your Docker desktop is running. Now, I can tell Docker desktop is running because there's this little whale icon. It's a little hard to see here, but it looks like a little whale with a bunch of crates on top of it, or a bunch of boxes on top of it. If that is running, then you're fine. If it's not, and you're on Mac, you should go to the little search and search for Docker and just run that program. If you're on Windows, again, I'm not super familiar with Windows. I believe it's the same idea. There's a little whale icon, but I think it's in the lower right, maybe. If you don't have that running, you'll need to go through your start menu and find the Docker program and start it up. If you're on Linux, then typically, oh boy, I think you need to use a sudo system control docker start command. But again, if you're on Linux, I'm assuming you have that taken care of. Okay, so this is the terminal I'm going to be using. Your terminal may look different than mine, and that's fine. Yours may have a white background or a different prompt or something like that. That's just how you've configured your terminal and is not anything to worry about. But I'll be using this terminal for most of this lesson. But just to give everyone a little bit of time to install things if they need to, I'm going to start by talking a bit about just what Docker is and why we use it. So a common problem in data science is that we're using very bespoke tools. We're using tools that we're writing ourselves in languages that can be very hard to maintain and hard to install. So for example, I maintain some neuroscience libraries. I maintain a library called NeuroHackademy, which is the Python library. And it's not too hard to install, but in order to get it installed, you need to make sure you have Python installed, and it needs to be a particular version of Python, like it can't be Python 2. You need to have certain versions of other libraries installed. You need to have NumPy and SciPy and a bunch of other support libraries. Your NumPy version needs to be compatible with your SciPy version. You can install versions of those libraries where they won't work together. And so there's actually a lot to do just to get you set up in such a way that you can use my NeuroPython library at all. And that can be really challenging, especially if the library is maybe a little out of date, like I haven't updated it in a few months, and now some of the libraries it depends on are out of date. Or for example, I published a paper many years ago that used this library, but the library's changed since then. And maybe you want to go and see what the state of the library was like when I used it so you can reproduce my analyses exactly. These are really hard things to do without some tool that helps you. So especially if you want to reproduce some old analyses using an old version of a library, that's very difficult. Because you not only have to install that old version of the library, you have to go find that old version and install it. You have to install all the old versions of other libraries that library depended on at the time that it was written. So this is a very common problem when we're trying to do reproducible research. We need to be able to run these old versions, and we need to be able to run the version that someone else ran when they ran their analysis. Docker is a tool that simplifies a lot of that. And the way it works is it's basically a virtual machine tool. So a virtual machine, this laptop is a machine. It's not a virtual machine, it's a physical machine. And it has an operating system installed in it, and it has Python installed in a bunch of libraries. A virtual machine is just a way of simulating a machine. So when in Docker, when we create a virtual machine, we basically install an operating system on some virtual file system that exists inside of my physical machine. And then Docker will simulate that operating system and run things inside of that virtual file system as if it were a separate machine. That's the basic idea behind Docker, and that's what it's most useful for. Now, the way that we configure Docker and interact with it is a little bit, can be a little bit unintuitive or a little idiosyncratic. That has a lot to do with the way that Docker is designed to both be a virtual machine tool and also to be a tool for sharing virtual machines and virtual machine configurations. So not only can I create a virtual machine with a separate operating system and libraries installed, but I can then share that. I can send that to one of you, or I can push it up to Docker Hub, which is a little bit like GitHub, and other people can use it and download it and run the same virtual machine. And a lot of the Docker tools allow us to declare kind of programmatically how we want our virtual machine to be built. And then I can just send that program of instructions to someone else, and they can rebuild the machine the same way. So that's kind of the idea behind Docker. Before I jump in, any questions on the general concept here? All right. So my hope is that everyone who didn't have Docker installed and wants to follow along had time to install it. If not, keep working on it. Not much I can do to help you. So to get started here, I'm just going to run a command, docker -- version. And this will just tell me that I have Docker installed and working. So all it's telling me here is that I have a particular version of Docker with a particular build number. This doesn't even tell me if the Docker program is running. So remember I said you have to have that little whale icon. You have to have Docker started. This will work even if you don't have that running. But if you don't have it installed, this won't work. Okay, so let's do something that actually interacts with the Docker system. So say Docker container, this will be our first real Docker command, ls. So what this command says is, hey Docker, give me a list. Ls is short for list in Linux usually. Give me a list of your containers. And here we have this, what looks like the heading of a table, which has the container ID, something called an image, a command, created, status ports, names. And there's nothing in the table, it's just empty. And that's because we haven't done anything with Docker yet. We haven't made any containers, we haven't downloaded them. So this is just telling us there's no containers. Now, if you got an error there that was something about cannot connect the Docker daemon, if you got that error, that means that that typically means that you don't have the Docker running. You installed it, but this little whale icon isn't running. So if that's your problem, try to start Docker and see if you can reissue the command. Okay, so Docker works with these ideas of containers, and the name for a Docker container actually got its name from the concept of a shipping container. So at least as I understand the story, I'm no expert on shipping containers, but as I understand it, many decades ago, shipping was very expensive and very difficult because there was no standardization of the kinds of containers that things were shipped in. And so every time a ship was packed, it had to be packed in a particular way that was idiosyncratic to the particular cargo they had. And so it was very challenging, and it was challenging to unload things. And all of that was revolutionized when shipping containers were standardized. And as a result of shipping containers being standardized, it was much easier for people to pack a container, to design ships, to fit containers, to get containers on and off of ships. And that just kind of revolutionized the shipping industry. And part of the idea behind Docker is that we want to standardize something similar. I mean, not really that similar, I guess, but something conceptually similar for programming, which is these virtual machines and our kind of compute environments. So that's why they're called containers. Just a little bit of history there. Okay. Additionally, there's another command let's look at real quick, Docker image ls. So as you might guess, this is going to give us a listing of images. Once again, it's going to give us what looks like the header to a table, but no actual data in the table, because we haven't done anything with images yet. Now, containers and images are conceptually similar. A container is an actual virtual machine. Typically, it's something that's currently running on your physical machine. An image is more like a snapshot of that virtual machine. It's a file, or it's like the whole file system for that virtual machine, all compacted into one sort of zip file. And if you have an image, you can take an image and turn it into a container, which basically starts the container running as a virtual machine on your computer. Okay, so let's actually do something with an image aside from just run these commands and talk about them. We're going to start with, it's traditional to start with hello world when you're learning a new programming language, so we're going to start with something similar. There is a Docker image called hello world. So we're going to say Docker poll hello world. This is a little bit like git poll. Git poll works with a particular repository, so it's a little different, but Docker poll basically tells Docker, hey, go up to Docker Hub, which is a little bit like GitHub, and find the Docker that's named hello world and pull it down onto our Docker system. Okay, so this will take just a second. It's got to download something, but basically it just succeeded there. All right, so now if we say Docker image ls, we see that there's this hello world image here. Now it's got something called a tag, which is kind of like a version. This is the latest version. It has an image ID, which is just a unique identifier for this image, and then some metadata about it. So we've pulled an image, and now we want to turn it into a container and actually, yeah, go ahead. Did other people get that error? No? Okay, so that may mean that you tried to log into Docker and you don't have the right password. If you go up to the Docker whale, there should be a sign in create Docker ID. Say again? Do you know if you have a Docker ID or a Docker username? Oh, okay. So probably what you did was enter the wrong password if it's giving you an authentication error. So I would try restarting it and try again. Yeah, if you have more trouble, we can try to help you. Okay. Other questions? Okay. All right. So we have this image. Like I said, an image is just a snapshot. It's not a running virtual machine. But if we want to run it, we can use a command, docker run hello world. And that gives us this message. Now, this message is from the hello world Docker. This is what the hello world Docker is supposed to do when it runs, is just print this big message to us. And it kind of explains how this message got to us, basically. First of all, the Docker client, which is the command we're entering, Docker, that's the command we're using on the command line is called the Docker client, whereas this whale thing that's running in the background, that's the Docker server. The Docker server actually manages most of our images and containers and stuff, and we just interact with it through this Docker command line. So it says the Docker client contacted the Docker daemon. The Docker daemon is the Docker server. Daemon is kind of a name for server in Linux parlance. The Docker daemon or server pulled the hello world image from Docker Hub. We actually did that ahead of time, but if we hadn't pulled hello world first, it would have automatically done that for us. The Docker daemon created a new container from that image, which runs the executable that produces the output you're currently reading. And then the Docker daemon streamed that output to the Docker client, which sent it to our terminal. So that's basically the flow chart of kind of what happened when we typed that Docker run command. And we're going to dive into some of these concepts a little bit more as we go here. There's a little more information here. We'll come back to some of that later. Okay. Oh, I created the image again? Yeah, so to do that, I just ran this command, sorry, the image. So to get the image, we did docker pull hello world. However, even if you hadn't done that command, the docker run hello world should still work. It would just pull the image first and then run it. Yeah. Okay, other questions? All right. So it has this suggestion here that we try something more ambitious, which is to run the Docker Ubuntu with the argument bash and some options here. The Ubuntu Docker contains just a straight up installation of Ubuntu Linux. That's what the Ubuntu Docker is. So if we were to run this command, what it would do is it would download the Ubuntu Docker, it would pull it, it would start up an instance of Ubuntu, and we would basically get a bash shell inside of the Docker virtual machine, inside of the running Docker container. We're not going to do that though, because Ubuntu is actually a pretty big piece of software and it takes a lot to download. And if we all try to download it all at once right now, it would probably slow all of us down quite a bit. So instead, we're going to use a much smaller image called Alpine. So let's go ahead and docker run Alpine. Oops, Alpine. So first thing it says is it can't find Alpine locally. That's because we haven't pulled it yet. So it goes ahead and pulls it. And then it seems to do nothing. Maybe, so, first impression might be that that was because we had to pull it on the same line. So let's just run it again. Nope, it does nothing. The reason for that is because this particular Docker container expects you to give it some more arguments. It expects you to tell it what to run when you start it up. So Alpine, basically Alpine is also a Linux distribution. It's just a very, very small one. It's kind of like Ubuntu, but with a lot of the bells and whistles taken out. So it's just a few kilobytes instead of many gigabytes. And so nonetheless, it's still a perfectly valid Linux distribution. And it expects us to give it some more information about what to do. So let's go ahead and do that. We can say docker run Alpine. And I'm just going to print, there's a file called /etc/os/release, which just usually tells you what operating system version you're running in Linux. So I'm just going to cat that. And what this is telling Docker is it's saying, go ahead and run this Alpine, take this Alpine image and run it as a container, as a virtual machine. And when you start it up, run this command, cat/etc/os release. Okay, so what it did was it started up that Alpine Linux virtual machine and printed out this OS release, which tells us it's running Alpine Linux. Now, notably, I'm not even sure if Macs have this file. Yeah, so this didn't run on my computer. That's ran inside of the virtual machine. Okay, questions so far? All right. Okay, so that was fine. But what if we want to do something a little more complicated? Let's suppose we want to actually go into the machine and interact with the Linux environment directly. So for this, I'm going to say docker run, and then I'm going to add some flags, -it. These are two separate flags. This is actually the same as -i-t. It's just a shortcut to put -it. But basically what this says, these two flags say are, when you start the Docker, I'm going to keep interacting with you. Don't start up the Docker and close the connection. I may type into the Docker and that kind of thing. So that's basically saying we're running this interactively. And then I'll say Alpine. And I'm going to run the command sh, which is just the shell command, so it'll start a shell. Okay.
I'm sorry, what the T stands for?
I don't remember offhand. Let's see if it's in my notes what the T means. One of them is for interactive, and I think the other one is for create a pseudo TTY. That's basically a fancy way of saying, like, I want this to not only be able to, I want to not only be able to interact with the Docker, but I want it to be able to print fancy graphics to my terminal screen. Fancy being like color, not like actual graphics. But basically those two flags together are what let you keep interacting with the Docker once you've started it.
Okay, thank you.
Mm-hmm. Other questions? All right. So here I have a prompt. And what this is telling me is that I'm in the directory /, which is just the root directory of this installation. And then this is just, you know, up here I have a $sign at the end of my prompt. Inside of this Docker container, I have a hashtag. And that's usually because I'm running as root inside of the Docker container. So I'm the admin of this Alpine virtual machine, but I'm not the admin of my physical machine. And so I have a hashtag here and a $sign outside of the Docker. But we can go ahead and enter commands here. So for example, I can say ls, and see there's all these directories here. I can cat/etc/os release and see that same bunch of text we saw earlier. So basically I'm logged into this virtual machine now and I can interact with it. Okay, so if I want to get out of here, I can just type exit. That'll end the shell, and then when the shell exits, the Docker container will shut down. Any questions so far? Okay. All right, let's switch gears just a little bit and talk about Docker Hub. We'll come back to the terminal in a minute. So if you navigate to hub.docker, I think it's .com. Yeah. You'll come to this this Docker Hub page, and it's this login here. You don't really need to log in to use Docker Hub, but let's go ahead and search for Alpine. And you'll see here that there's this this entry here when we search for Alpine for what's labeled a Docker official image of Alpine. Docker Hub is actually, it's a little bit like GitHub in that it stores Docker images, and you can push to it. If you have a Docker account, you do have to pay for it, but if you have a Docker account, you can push to it and store Docker images there. Even if you don't have a Docker account, you don't pay for it, you can pull images down from it and run them locally. And that's exactly what happened when we said Docker pull. When we said Docker pull Alpine, our Docker server connected to Docker Hub found the Alpine image and downloaded it for us and stored it somewhere in the Docker's own kind of internal storage. So you can go to this Docker Hub and find all kinds of images. There's tons and tons. There's images I maintain here. So if you search for NeuroPython, which is my library, there's a Docker here called nben/neuropython, which is the Docker image I maintain that has an installation of my Python library inside. And the point of this is that other people, if they don't want to have to install my library and all its dependencies, they can just download the Docker image and start up an operating system that already has that all installed. So if we have time, I'm not sure that we'll have time, but if we have time, I'll show you an example of that later. So Docker Hub is where all these images are stored, and that's kind of where we pull from. Yeah. So let me rephrase that. I don't think you have to pay to have an account, but I think you have to pay to store images in Docker Hub. Yeah. So I have this image pushed here because I have a paid account on Docker Hub, and Docker Hub will store that image for other people to download. This isn't the only way to do this. You can take an image and you can make it into a file, and other people can load it from a file. So for example, a few years ago when I published a paper, I made a file and I just published it on Zenodo, which will archive, basically it'll save up to like 50 gigabytes worth of files for free and give them a DOI so you can reference them in a paper and stuff. And that way you don't have to pay for Docker Hub. You can just put your images on Zenodo. This is just a convenient way for other people to get at them. Is what I would say. It's a little bit like GitHub in that sense. Yeah. Other questions? Okay. So typically, Docker images are named according to a certain format. And it's a little bit like this. It starts with the username of the person who owns the Docker image. My username on Docker Hub is nben, which is why this starts with nben. And then there's a slash, and then there's whatever name the person gave the Docker. So I call this Docker NeuroPython. And then typically there's a colon and then a tag, like a version tag. So if I go over to this little tab, this is actually very small. Let me make this bigger. If I go over to this version tag here, or this tags tab here, you'll see that there are various tags of different versions of this Docker. And so if you don't specify a tag, Docker assumes you mean the latest tag, the most recent one. But if I go back to the terminal now, I could, for example, git poll and then / neuropython :latest. Oops, latest. I'm not going to run this because it's also it'd be many gigabytes and it would take a while to download. But for example, I could put git poll nben neuropython latest, or I could put git poll nben neuropython 0.5.0, which, oh, sorry. Oh, thank you for catching that. That should be docker poll, not git poll, different command. Yeah, docker poll nben / neuropython : 0.5.0, and that will go and pull that particular version of that Docker image from Docker Hub. Okay, so let's do an actual example here. Let's go ahead and Docker poll, and since we use a lot of Python, let's go ahead and do Python : 3.8. Now you notice there's no user on this Python Docker, and I believe that's because it's a Docker official image. So Docker official images don't have usernames. Any other Docker image will typically have a username. That'll take just a second here. You'll notice some of these are very big, or they seem to be very big. A lot of times you'll pull a Docker image and it'll end up being something like 50 gigabytes. It's not always actually that big. Docker is very smart about reusing layers of reusing data that already exists that you've pulled previously, or data from other images and things. So a lot of times it seems like you're pulling this huge image and you're actually just pulling a little bit. All right, this is taking just a little bit. Okay, that took a little longer than I expected, but nonetheless, that works. And I actually don't know how the Python 3.8 one runs, but let's go ahead and try. Okay, and that just opens up a Python interpreter inside of that Docker image. Now, if we want to verify that we're inside of a Docker image, I suppose we could import the OS module and do a listing of something like the root directory, but this is getting a little in the weeds. So the point being that we could download this particular version of Python and run it. And if we needed, if we needed to run a different version of Python, because, for example, you needed to run an analysis I had run in Python 2.7 or something, you could download Python version 2.7 and run it that way. All right, so let's go over a few more just kind of utility commands before we start actually making our own images, which we'll do in a minute here. So far we've downloaded a few images. Let's go ahead and run that docker image ls command again. We can see the Alpine, the Python, and the hello world which we pulled. Now notice that there's these image IDs. These are just unique tags I think I mentioned for every Docker image. And if, for example, we are done with this Python image, and notice it's like 861 megabytes, so we want to get rid of that and clear up that space. What we can do is we can run the docker image rm command to remove that Docker image. And what we do is we give it the image ID here. So in this case, D00AB4. I believe you just have to type enough of the image ID that it's unique. So I'm just going to stop there. Aha, it says we cannot delete this image. And the reason is because it's being used by a stopped container. Okay, so let's go see what container is maybe using this image. So docker container ls. So this seems like a bit of a mystery. There's no containers in our system, and yet our image seems to be used by a container. But notice that it says it's being used by a stopped container. And when you ask Docker for a list of the containers, it's only going to show you containers that are currently running. So if we want to see all the containers, we can say docker container ls -- all. And now we see here's the container that we just ran 2 minutes ago of the Python executable. Here's the Alpine where we ran the sh command. Here's the Alpine where we ran the cat/etc/os release. So notice that there's a container for every Docker run command we issued. There's not a container per image. There's a container every time we start up. We take an image and start it up as a virtual machine. That's kind of the part of the difference between containers and images. Again, the images are snapshots. The containers are running instances of a virtual machine. So even though we're done with these virtual machines, we've exited out of them, there's still a record of that container having been run. Yeah. Yeah, so for the people on Zoom, the question was, at least some people here have much bigger images for their Python, like 900 megabytes instead of 800 megabytes, and they're wondering why. And I am not certain why. I have some, I can speculate, but I guess one question is, do you have the same image ID that I do? Okay, so probably that means that for whatever reason, you downloaded a different version of the same repository, and I don't know why that would be, but yeah, I'm a little surprised by that, honestly. So, and you just ran this just now. You've not used Docker like in previously? Yeah. Right. Yeah. So if I had to guess, actually, the more I think about it, I'm guessing this is not specific to. This is more likely related to the version of Docker I'm running versus the version of Docker you're running. Is that different versions of Docker may have different compression or different ways of storing the images, and so it's that would be the most likely explanation I can think of. Yeah. Okay. Oh, really? Okay. Yeah. So that would be my next guess, is that there's something about the way either that my file system is storing these things or the way that I have previous layers of images stored on my computer already that may have caused that to be different. Yeah. 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 Well, as long as this keeps working, I'm not too concerned about a small difference in the size, but typically that wouldn't exist. My guess is that it has to do with some extra thing we're not accounting for, like differences in the way that my file system is set up or something. But yeah. Yeah, no, that's a good catch that those are different. Any other questions before I go on? All right. So we couldn't, right. So we now know that there's a bunch of stopped containers that are sitting here that we had kind of forgotten about. Since these containers all depend on whatever image they were started from, those images can't be deleted until we delete those containers. And the reason for that is that Docker assumes that even though we've stopped that container, we might want to run it again, or we might want to take it and we might want to turn it into a file. So for example, when we started Alpine with SH, we could have installed Python inside of Alpine. And then inside of that virtual machine, Python would be installed. And then when we exited out, we wouldn't want to lose that. We might want to take a snapshot of that updated Alpine image as a new image that already had Python installed. And so we wouldn't be able to do that if as soon as we exited, Docker cleaned up that container and just deleted it all. So Docker does this for a reason. It's so that once we've exited, we can either restart the container and do something else to it, or we can save the progress and come back to it later or something like that. But for now, let's suppose we just want to get rid of these. We've demonstrated them, demonstrated the purpose here, and we want to get rid of some of these containers. So I'll go ahead and start with this first one, the Python container. So I'm going to say Docker container rm, and then I'm just going to copy this string here, which is the container ID for that Python container. And now, if I type Docker container ls-ol, we don't see that Python container anymore. However, if I type docker image ls, deleting the container doesn't delete the image. The image is its own thing. It's a snapshot independent of the container we started. So if we want to delete the image, we can now docker image rm. I'm going to copy and paste that ID again. And since we deleted the container that that image depends on, we can now delete the image. And here you notice it's giving us a bunch of hashes for things it deleted. This is basically gobbledygook, but what this is telling us is the specific things in the Docker system it's cleared away for us. And mostly this isn't important, but for larger Docker images, there'll usually be a lot more of these, and that's about all there is to that. Any questions on that? Yeah. Yeah, so that's a great question. So the question was kind of two questions. First of all, is it a good idea to delete Docker containers as you are done with them? And secondarily, where is all this stored on the local machine? So I'll answer that first one, or that second one first, which the answer is I don't know. And it doesn't really matter. Docker manages all that for you. And I suspect that on every operating system, it's in a different place. And it's in files that don't make sense and aren't human readable. And like it's a database of binary stuff. So it's not something that you tend to worry about. However, it is a good idea if you're pretty sure you're done with the container to go ahead and clean it up. And in fact, that kind of segues into a great point here. So let's go ahead and say Docker container ls-ol again. So here we have our record of everything. Actually, let me go ahead and teach you a quick command. If you run out of space on your computer and you realize that what's happened is Docker is eating up all your space, this happens surprisingly often because it's easy to forget about images and containers you run and easy to just leave them lying around. There's a command, docker system prune -a. This will clear out all of your images and containers and free up all your space. And I'm actually just going to run it now because there's nothing on here that I need to keep around. It's going to give us this warning and say that, are you sure you want to remove everything? I'm going to say yes. And now if we do a Docker container ls-ol, everything's gone. And all the images are gone too. So that's a single command that you can use to clear everything. There's another version of it, I believe, which is Docker container prune and Docker image prune if you just want to clear the images or the containers. So that's an easy way to get rid of everything. Okay, and then there was another thing I was going to demonstrate. So let's once again run our Alpine image. Yeah, okay. So I'm going to run the Alpine image with the sh command one more time. And this time, I'm going to go into it with the assumption that this is just a one-off thing I'm going to run. I don't want to keep this container around. I just want it to go away as soon as I'm done. And honestly, a lot of commands, Docker run commands I don't want to keep the container around. A great example of this is that it's very easy to take a single analysis and wrap it in a Docker so that you Docker run, and then you give it like a path to your data, and it will go inside the Docker, do the analysis, and spit out the results, and then it's done. You don't want to keep that container around. Its job was just to run the analysis. A good example of this is Fmri prep. If anyone's used Fmri prep, the Fmri prep Docker is designed so you give it this really long, complicated command line, but then the Docker does all of Fmri prep inside the Docker and writes all your data out. And when it's done, you don't really need to keep that container around. So if that's the situation you're in, you can give it another argument, which is --rm, which basically says, as soon as I exit this container, delete it, clean it up, so it's not on the system anymore. So since I did that system prune command, it has to pull the Docker, which it just did, and then it's going to start up the Docker container. And now, so let's see if I can remember the command for installing stuff. I believe Python 3 is not installed here. Yeah, so there's no Python inside of Alpine. But we can use a command that comes with Alpine called apk. If you're familiar with Debian, apk is a little like apt. Or if you're familiar with, on Mac, there's like brew and Mac ports. These commands are all kind of similar. This is a package manager command. We can say add --update Python 3. And let's go ahead and install py3-pip. Pip is the package manager for Python. And that'll go ahead and install Python inside of this image. And now we should be able to type Python 3 and have it start a Python instance.
When I ran Fmri prep for some other project, and I think there was some issue with the Python version. So I just wonder if that's consistent with other like Fmri prep softwares like QSI prep or something. Is that translatable? Well,
so my suspicion is that if you had a problem with the Python version inside of Fmri prep, that's probably very unique to that particular version of the Docker you were running. But I'd need to see the error to be certain. Generally speaking, I don't think that the QSI prep Docker image, the Python installed there, has very much to do with the Python installed inside of Fmri prep. So assuming I'm understanding your question right, I think that's probably idiosyncratic to the particular version of Fmri prep you were running.
Okay, thank you.
Mm-hmm. Okay. So we did all this work to install Python, but when I exit here, if we then do a Docker container ls-ol, that container is gone because we used that --rm flag. And so all that work we did installing Python is also gone. And our Alpine Docker image will still be the original Docker image. Yeah. Yeah. Yeah, yeah. Here's the command. I'll leave that up for a second.
This may be kind of derailing of this lecture, so please excuse me, but in this, at UW, I think that my lab is kind of advising towards singularity or pushing towards singularity versus Docker. And I wonder, I'm very new to this, so I wonder, can you explain why?
Yeah, so Singularity is very similar to Docker, but they're a little bit different. So I haven't used Singularity a whole lot, so I am not super keyed in on the very specific differences between them. But one of the main conceptual differences is that Docker has this server client model, which is good for a lot of reasons, but also means that if you're running it on a cluster, like a compute cluster or a high performance compute cluster, typically you cannot run Docker on those kinds of clusters. And the reason for that is because the server needs to run with root permission, with admin permission. And if you allow if you allow people to run tools that have admin permissions, that's a big security risk. And so typically you can't run Docker on a cluster. However, it's often very useful to use a cluster to run a bunch of analyses that are all Dockerized, that are all inside of Docker images. So if you have a data set that you've collected and you want to run my NeuroPython tool, do some analysis from it on all the subjects in your data set, a typical good way to do that would be to just use my Docker and not have to worry about installing things and getting things configured, and to just say, yeah, for every subject, start a Docker image and have that image run the analysis. But you can't do that on a high performance compute center because Docker needs root permission, so you're typically not allowed to. Singularity is a way of running Docker images or Singularity images, which can be built from Docker images without having root permission. So it's sort of like a way around that problem. That I think is the main reason a lot of people use Singularity in the kind of like in a lab context. Beyond that, there probably are other differences. I just am not familiar enough with the details of Singularity to be certain what other reasons there might be. But that's definitely one of them.
Thank you.
Any other questions? Yeah, okay, so the question was, for those on Zoom, is, so Docker is for sharing images, and if you don't want to share, would you just use Singularity? Potentially, it kind of depends. I think that you can also share Singularity images, I believe, although I think there is a user-specific aspect to it. Again, I unfortunately haven't used Singularity enough to be able to answer that in much depth. You may, yeah, I mean, I think that Singularity is probably a better tool, mostly for compute clusters. I think that's the main use case. Yeah. Other questions? Okay. Okay, so let's go ahead at this point and actually make our own Docker image. So I'm going to CD into my desktop for this work. I'm going to make a directory. Let's just call this basic image. I'm going to CD into it. And typically to make a Docker image of our own, we create what's called a Docker file. So I'm going to use the Nano program for this. You can use whatever text editor you're comfortable with, but typically everyone has Nano installed, so I'm going to use Nano. And I'm going to open a file called Docker file with a capital D. That capitalization is actually important, so make sure you capitalize it the same way. Whoops. Nano Docker file with a capital D. Okay, so Docker files are sort of like the source code files for Docker. They're specifically for building an image. They aren't for building a container. Once you've built the image, you can turn the image into a running container. But this is for how you build the image. And it has its own syntax, and the syntax is very, very simple. So for the first line, we're going to start with the command from. And basically from says, start with some other Docker image. That's where we're going to start. So let's go ahead and start with Alpine, which is the one we were just looking at. So what this says is we're going to make a new Docker image, and it's going to be based on the Alpine Docker image. we're then going to run something inside of an instance of this image. So we're going to run that installation command we ran, apk add --update python 3 py3-pip. So that's the same command we ran before. So what this will do is it'll install Python 3 and pip inside of our new image. Let's go ahead and add one more command. We'll run, because once this command has been run, we'll have pip installed. So we can go ahead and say pip install, let's try NeuroBabble. So NeuroBabble, if you're not familiar with it, is a neuroimaging file format library for reading in things like Fmri files and stuff. And then finally, we're going to put a line that says command /bin/bash. Now, what the command line is for is this tells Docker that when we start the Docker as a container, it should run this command. So when we say Docker run and run our new image, it starts up the container and runs that command. So I'm going to push Control-O, save it as Docker file, and then push Control-X to exit. Just to make sure the changes were fine, I'll cat the Docker file. So there it is if you still need to type something in. Okay, so we have this Docker file. Now we want to turn it into a Docker image. And the command for that is docker build. And we need to give it a name. So I'm going to say -t. Since my username on Docker Hub is nben, I'm going to call this nben/alpine Python. And finally, I give it a directory, which is the directory that contains the Docker file. And that happens to be our current directory. So I'm just going to put dot. For those who are not super savvy with the Linux conventions, dot always refers to your current directory, whatever directory you're in. Okay, so when we run this, this is going to take a minute or two because it needs to run all of our commands. But you see here it's running pip install right now already. The pip install may actually take longer than everything else, but it's already run the Python install. This should, okay. So that didn't work because NeuroBabble is too complicated. It relies on NumPy, and NumPy isn't built for Alpine. So I should have known that wouldn't have worked. So let's edit our Docker file real quick. And instead of installing NeuroBabble, let's install Python, which I'm pretty sure will work. So I'm just going to change that pip install NeuroBabble to pip install Python. Save this file out again, and then exit. And then I'm going to issue that build command again. So docker build -t. For me, I'm going to do nben/alpine Python, and then dot for the current directory. And you'll notice that those first couple commands ran real fast, and that's because we already run them, and Docker remembers that. So it remembers that in the last time we tried to build this, all of this part worked up to step 3. And so it skips those because it already knows the result of running those and just starts right there. So what we can see from this message here is it went ahead and loaded our Docker file in. It pulled the latest version of the Alpine Docker image, which we already had here. It ran our install, it ran our pip install, and then it basically was done. So if we now say docker image ls, we can see this nben alpine Python image that we just created. And if we docker run -it, because we want to interact with it, nben/alpine Python. Oh, shoot. Bin bash is not found. That's funny. So the problem there, remember when we ran Alpine the first time, we used the sh command, which stands for shell. Typically, that actually just runs the bash command. I guess I wasn't aware that Alpine doesn't have it labeled as bash, so we're just going to have to change that to sh. So let me open up that Docker file one more time and just change the command to sh. I'll save that out and exit and build this one more time. Okay, that ran real fast because it actually didn't need to redo anything. It just needed to change the command on that Docker image. So now we can docker run -it and Ben Alpine Python. And there we have a prompt. And now to test that all that worked, we can open up Python 3, which is already installed in this version of Alpine because we put that in our Docker file. And we should be able to import Python. And that all works. So what we've done here is we've created a new Docker image with stuff installed already. And we did it using this simple text file, Docker file. And part of the beauty about this is that I can then just take this Docker file and give it to someone else. And if they build that same Docker file, they'll have an identical virtual machine on their computer up to any particular versions of things that got installed using these commands. So for example, when I ran pip install Python today, it's going to install a particular version of Python. If you then run it a month from now, it may install the next version of Python. So we may not get exactly the same container, the same image if we build it at different times on different computers, but we should get pretty close to the same image. And additionally, there's still this image here that I have on my computer that I've built. And so I can use the command docker save. And by the way, I just want to add that pretty much all the Docker commands except this argument --help, which can tell you information about how you use it, just FYI. So there's a command docker save, and you can say -o for output, Alpine Python dot, and I think these are typically tar.gz files, nben/alpine Python. And what that will do is it'll take that image and it'll save it as the Alpine Python.tar.gz file that I just specified here. So what this did was it took the image I created and it saved it to a file. And I can now send this file to anyone and they will have the exact version of the image that I built. So this is a way that I can basically build a bunch of tools or install a bunch of tools inside of an image, get it all working with my libraries or whatever analyses I'm doing. And then I can just publish this Alpine Python or whatever image I build to like the Open Science Framework or to Zenodo, and anyone can come along and have the exact same code and the exact same operating system and installation and everything for running their analyses using my code. Any questions about any of that so far? Yeah. Yeah, so for one, let's just go ahead and look at them a little bit. So the Docker file is a text file that just has those commands in it. And notice it's only 80 bytes long, right? The Alpine Python.tar.gz, which we created with the docker save command, that is the entire operating system inside of that Docker container saved out to a file. And it's the container that resulted, or I should say the image that resulted from that Docker run file. But when we did Docker build, it's sort of like compiling a Docker image from our Docker file, which is sort of like the source code. So it takes that source code and uses that to generate this image with particular things installed. And that's all managed by Docker's behind the scenes file management stuff. And then when we say Docker save, it says, okay, I'm going to pull that image out of my file management stuff and put it on your file system in this file you specified. So there's actually, I believe it's Docker load. Yeah, you can. So if I sent you this file, you could run Docker load on that file, and it would take that file and put an image on your system that is exactly identical to the one on my system. Yeah, did that answer your question? Okay. Yeah, the Docker, the way to think about it, I think, is that the Docker file is instructions for making a Docker image, for setting up an operating system. And what you save is the operating system itself, like a stamp of the state of the operating system.
I have a question, a follow-up to that prior one, if
Uh-huh.
that's okay. If I'm interested in preserving the exact installation, it is better than to share the tar.gz file that's saved instead of the instructions, right? Because if someone builds into the future.
Yeah, so it depends, but generally speaking, that's correct. So in particular, if you're worried about preserving the current state of your code for future people to be able to run and reproduce, you definitely want to share this tar.gz file because, like you say, the installations inside the Docker file, they're just instructions, and those libraries may change, and you may get a different version of the library when you build the Docker again. However, if you're distributing something so that other people can do a lot of work on it, like it's the purpose isn't primarily to document and establish something reproducible, it's more of like a workspace, then oftentimes you want to distribute the Docker file because people may want the most recent versions and they may want to build it themselves. So it kind of depends on your use case. But in general, if you're like, what I would say is if you're publishing a Docker image as part of a paper or something, you want to publish this tar.gz file and not the Docker file itself. I'm sorry, I think you had a more question. Okay, perfect. Yeah, any other questions? Yeah. Yeah, so the main reason for people on Zoom, the question was why create this tar.gz file instead of just pushing the image to Docker Hub? Yeah, and in fact, because I have a Docker account that I was paid for, I can just Docker push in Ben/Alpine Python. Whoops. And it will push it up to Docker Hub, and then you could all Docker pull in Ben/Alpine Python, and that would work. I'm not going to run that because I don't want this to be permanently part of my Docker Hub account right now. But that would work. However, there's some disadvantages in that. One is that you have to pay for Docker Hub in order to be able to store Docker images there. Whereas you can make these tar.gz files and I can just email them to you or put them on Google Drive and send them to you, or I can publish them using Zenodo, which is free. And then you can download them that way and load them in. And it's just like if you had pulled them from Docker. Okay. No, you're probably right. So for Zoomers, he was just observing that he was able to push his Docker image. So it's probably, this is just a guess, but probably the Docker's pricing has changed so that you're allowed to push some number for free or something like that. It used to be that they were all for free and you could just push everything for free. And now you have a limit of some kind. Yeah. Oh, okay. So that's, gotcha. Okay, thanks for the update. So you can only have 3 private images. You can push as many as you want. So that's I'm not sure when that happened, but there was a period where you couldn't actually even push unless you had an account. So that's great. I'm glad to hear they've brought that back. Any other questions? Okay. Oh, yes. Yeah. Yeah, so that's a great question. For the Zoomers, the question was, can you specify the version of Python you want to use in the Docker file? So you can. It's not part of the Docker language exactly, but if we open up this Docker file again, pip actually knows how to install particular versions. So if, for example, I don't know the current version of Python, but let's suppose it's 1.11. You can say Python equals 1.11, and it'll install exactly that version. You can also say, for example, Python is greater than equal 2.0, that kind of stuff as well. So Pip can handle that. It's not part of Docker, but Pip can do it for you. Yeah. It can't find import. Oh, did you run Python 3 first? So you have a three arrows? Yeah. So import Python is a Python 3 command. So you have to run Python 3 and then run import Python. Yeah. Okay. Yeah. Mm-hmm. So if you can call it something other than Dockerfile with a capital D, I'm not aware of it. It might be that there's an argument somewhere, but I have never seen anyone use it that way. And I believe that you have to have it called Dockerfile with a capital D. This has to do with permissions things that Docker manages. So yeah, so for example, you're also allowed to, there's a command for the Docker file called copy. So like we used from and run and command. The copy command will take files on your local computer and put them inside of the image. And one of the things that Docker enforces is that you can't take any files outside of the current directory and subdirectories and put them in the image. And that's just a permissions thing. And it has a lot of weird rules around the way directories are managed relative to Docker. And I think this is one of them, is that the Docker file has to be in the root of the directory that builds it. Yeah, go ahead. Sorry, -F. You mean like for what command? Oh, really? Okay, so you can do -F. Okay, yeah. Like I said, I'm not familiar with that. So again, I've never seen anyone use anything but Dockerfile with a capital D. It does have to be part of the subdirectory you're in, but I guess you can call it something else. So yeah, thanks. Any other questions? Okay. All right. So something else I want to mention real quick. We can do Docker image ls here, and we have some images here. Notice that this image we built is just tagged as latest, but we maybe want to say that, okay, this is version 0.1 of our Alpine Python Docker. So to do that, we can use the docker tag command. And basically what we do is we say docker tag, and then we can either provide it with a Docker image name, or we can use the image ID. So I'm going to say we want to tag this Docker, so the Alpine Python Docker, as having a particular version. So we want to give it the 0.1 tag. And now if we say docker image ls, there's two copies of these, one that's 0.1 and one that's latest. And it says that they both take up 82 megabytes of space, but it's the same 82 megabytes for both images. Since they're identical, it doesn't actually take up any more space. But this is how you can rename Docker images this way, basically by making a duplicate that has a different tag or a different name. Okay. Let's do a slightly more complex example. So we've got about 20 minutes left, so I think we can probably finish this. Okay. So, all right. So first of all, in order to do this example, we're going to go back to the reproducible computation page. This is the page for this this lesson. I'm going to drop this in the Slack one more time, just so everyone has it. Right. So if you go to this page and you scroll down a little bit, there's a setup link here. And there is a docker intro.zip file here. Just go ahead and download that. And then I'm going to go back to my terminal. I did this on Mac, so this got downloaded to my downloads directory. So I'm going to move /downloads /docker intro.zip to this directory, and then I'm going to unzip it. Okay, and really the only file we wanted out of this was this sum.py file. I just didn't want to rewrite this this file in front of you all. All right, so let's so just to be clear, we just unzipped that, so we now have a directory called Docker intro here, and inside of Docker intro is a directory called sum, and inside of sum is this sum.py file. And just to show what's in there, basically this is a very simple little program that just lets you type in some numbers and it adds them together. So this is just a stand-in for whatever complicated, crazy neuroimaging Python analysis we wrote. This is a very simple example, but it's sort of supposed to represent some analysis that we want to package up inside of a Docker image for other people to use. Yeah. Oh, sorry. So you have to download the docker intro.zip file. Oh, okay. So if you go to the link that I sent, it should look like this, kind of. Yeah, if you scroll down, there's a link to setup. Yeah, sorry, I went through that kind of fast. And then there's the docker intro.zip. And then you just want to unzip that that file. Just in for anyone who's having trouble finding that, I'm just going to stick it in the Slack as well. So you can copy and paste that into a file if you need to, rather than downloading it. Okay, so we're gonna use this. We're gonna package this Python file up inside of our Docker so that other people can run it. That's kind of the idea here. So I'm going to start by opening up our Docker file again. Okay. So I mentioned the copy command, and make sure we've got this right. Okay. So we're going to go ahead and run copy docker-intro /sum/sum.py. That's where that sum.py
There's a
file
typo
is.
there.
I'm sorry?
Intro, it's not into. There's a
thank
typo.
you. Intro sum.py. And I'm just going to put that in /sum.py. So what this is saying is take this directory on my local computer, or this file on my local computer, and copy it into the Docker image at this location. Okay. So I'm going to go ahead and write that out and exit, and then we're going to Docker build. And I'm going to call this Alpine sum. And we're going to build the current directory. Okay, so now just to demonstrate that that worked, let's go ahead and Docker run -it for interactive, --rm because we want to clean this up when we're done. And we'll run Alpine sum. And if we type ls inside of this Docker image, you can see the sum.py file right here. So all that copy command did was take that sum.py file. We can even see it to make sure it's the same file, and it copied it into the Docker image. Okay. So now let's suppose we want to run that file inside the Docker. So we can use a similar command, docker run -it-rm. And we're going to run the Alpine sum Docker. And we want to run Python 3 sum.py. Sum equals 0. So why did it do that? Well, because what this program does is it takes the command line arguments that you give it and it adds them together. So let's do that again. I'm just going to push up to get the same command back so I don't have to type all that again. And I'm going to say 10, 11, 12. And that tells us the sum is 33. So this is a very basic way that we can run this command inside of the Docker container. We can just provide the command line here. Okay, any questions on this so far? All right. Now let's suppose let's suppose that I'm going to go edit our Docker file again. Let's suppose that we don't have this sum inside of our Docker image. So I'm going to delete this line out again. Save that and exit. And then I'm going to Docker build Alpine no sum dot. Okay, so let's suppose that we've got this version of this Docker image built. It doesn't have the sum.py file inside of it, but it does have all the right libraries installed. It's got Python and it's got Cython and everything we need to run the sum.py. So one thing that we might imagine is that we could say Docker run -it-rm Alpine no sum, and then we could say Python 3, and then we could just say, okay, let's run our local sum.py. We've got it right here. It's in the Docker intro /sum/sum.py file, and then 10, 11, 12. Oh man, I'm making a lot of typos today. Okay, so this might intuitively seem like it'll work because we have Python 3 installed inside the Docker. It should be able to run this code. However, it won't work. And the reason is because there's no Docker intro sum.py inside the Docker image. Inside the Docker image, it doesn't know anything about the file system outside of the Docker image that we're running it from. So if we want to be able to do this, we can. It just takes an extra argument. So we can say Docker run -it-rm, and then we can provide it with what's called a volume, and that's -v. And a volume is basically a directory and all of its subdirectories on your local computer that you just kind of transpose into the inside of the Docker. Now, this is not the same as the copy command. The copy command actually makes a copy of some file inside the image. This is different. This is like your file system is inside the Docker while it's running. So as an example, I'm just going to say /docker intro /sum. And then we put a colon to say that now we're giving it the path that we want this to be on inside the Docker. And I'm just going to put it in /sum, a directory that will exist inside the Docker. And we're going to run an Alpine no sum. And we're just going to run the sh command. Whoops. Includes invalid characters for a local volume name. What am I doing wrong here? Sorry?
It might be the intro. Docker /intro and / being a
I typically would expect that to work. Check my notes here. Huh. Yeah, this let's try it with a slightly different command line. No, and well, let's try that. Actually, you might be right. It might require an absolute path now that you mention it. Yeah, that was it. Okay, so okay, so yeah, I'd forgotten that you have to provide an absolute path. So this is also related to the weird Docker permission issues that have to do with preventing you from accessing files outside of your current directory or outside of whatever directory you're running from. That's part of just permission since Docker runs with admin privileges. Okay, so we're going to run this. We're going to run it. Whoops, I've got another typo. We're going to use the --rm so that it cleans itself up, and we're going to run with -it so that it's interactive. And then we're giving it this volume. So $PWD stands for print working directory. Is that right? Anyway, basically $PWD is whatever directory you're currently in. So let me just hold that for a second. If we just echo $PWD, it'll tell us we're in my home directory /desktop/basic image. So when we run this, it'll basically turn this into an absolute path, and it'll mount it in /sum inside the Docker image. Okay, and now if we type ls, we can see that there's a directory sum. If we cd into sum, we can see that there's the Docker file here and this file sum.py. And again, this is not copied, this is the actual file system. So for example, if I echo test into a file test.txt, we can now see this file test.txt here. And if I now exit, if we look at Docker file, Docker intro /sum, which is the directory we mounted, we can see that test.txt as well. So that's just to demonstrate that when you use this volume mount, what you do is you take some directory on your computer and you put it inside the Docker while it runs. And that's a way that you can give the Docker input. That's typically how you give input to Fmri prep, like your subject. You mount a volume with the subject. And additionally, it's how you get your output. So when Fmri prep runs all of its analysis, it writes all of the results to an output directory. And typically what you do is you mount, you provide this volume argument so that the output directory inside of the Fmri prep Docker actually writes to some directory on your local computer.
I have a question pertaining, sorry.
Go ahead. Go ahead, Zoom person.
I have a question about updating files. Say I run a program that, I don't know, creates a file that already exists in my local volume. Does it rewrite? Could we specify which file to keep or how to handle?
Yeah. So when you run something inside of the Docker image that modifies your local file system through a volume mount, it's just like if it treats it exactly the way that the operating system inside the image would treat it. So you don't have the option to say, yeah, I want to keep the version before Docker ran. As soon as the Docker image makes the changes, typically they go to your local directory. So so it's just like running any program on your computer, really, that has access to those files. Does that answer your question?
Yes, thank you.
Okay, and you had a question? Yes. Yeah, so for Zoomers, the question was, does this directory here on this side of the volume mount have to be the same as this directory name, or is this some significant? The answer is no. This can be any directory, any valid directory name. And just FYI, you can also mount files. It doesn't have to be a directory. And the file or directory doesn't have to exist inside the Docker. It'll get created when you use the volume option. Yeah. Okay, any other questions?
I have a quick question, clarifying question. So just looking at the arguments for -v, which is volume, right? The /sum that's after the semicolon, so which one is actually going to which? I'm just confused which is the output and which is the input.
So what this, so let me get this highlighted here. What this option here says is that this directory on our local computer is the same, becomes the same as this directory inside the Docker.
Gotcha.
Yeah, so so you can think of them as just, it's sort of like a mirroring or something. It's not, yeah, it's not a copy, but yeah, this is the inside the Docker, and this is the local machine.
I see. Thank you.
Okay, any other questions? All right, so we're pretty much out of time here. I covered just about everything that I was hoping we'd cover. The one thing we didn't get to is, which I think we can just do in a minute here. So I'm just going to open up the Docker file one more time. Now we've looked at some pretty particular use cases for Docker. And in particular, this command, you notice that we had the command, but I sometimes provided a different command, like I would run Python 3 instead of running sh. That's totally allowed with the command, the cmd command in a Docker file. What's typically more useful, though, is what's called the entry point. So there's an entry point command, and that basically takes the Docker run command, and it always runs whatever you put in the entry point command instead of letting you override the command. So to demonstrate this, we're going to run Python 3, and we're going to run the /sum.py command. And actually, I think I need a comma here. Now, notice that this is, we have these square brackets, and we have Python 3 and sum.py in these quotation marks. That's just the syntax for providing these kinds of entry point commands. This is just a list of the arguments, starting with the thing you run and then the first argument. And then whatever arguments you put on the Docker run command will get appended to this. If you have an entry point, you can then use the command to provide extra arguments, or default arguments, I should say. So for example, we could add 10, 11, 12. And those will be the default arguments that get appended to this entry point when we run it. Yeah. In the command? Yeah, so I'll show you that in just a second. So let's go ahead and actually I'm going to go ahead and re-add copy Docker intro /sum/sum.py to /sum.py here. That's just so we always have the sum.py inside the Docker ready to run. So I'm going to go ahead and write that out and exit out of here. Let me cat this so that anyone who's trying to copy all that down still has it there. I'm going to build this Docker. We'll call this Alpine sum again. Okay, hopefully you can still see this if you need to be copying. Okay, so now I'm gonna run that. I'm gonna use --rm and -it again. The Docker we're running, since we put the sum.py inside of the Docker, we don't need to do the volume command this for the volume argument this time. So I'm gonna say we're gonna run. Whoops, I just named that Alpine sum, so it's not in ben/alpine sum. And then I'm not going to provide any arguments. And notice that it comes up with 33. That's because when I don't provide arguments, it uses these as the default arguments, and it always runs this command. Now, if I hadn't put entry point and I just put command, and I'd put command Python 3 sum.py, then I would be allowed to run something like this and start an sh command. And it would ignore whatever was in the command and just run sh. But if I do that this way, it says please supply an integer, because the entry point doesn't allow you to overwrite it. If you put an entry point, when you Docker run, it always runs this and provides whatever arguments you give to the end of the Docker run command to the entry point command. The command is actually a way, this cmd, sorry, too many things are called command. This cmd command is a way of saying, here's the default arguments that get passed into the Docker if they don't provide any. So there's sort of, they're similar in that you can put the command in the command if you want to, but they serve a different purpose. So if you use the entry point, the user can't override the program that gets run. Okay, any other questions? I think we're actually a little over time at this point. So, but yeah, go ahead. You mean, does it include subdirectories? Yeah, so the question was, when you use the volume argument, is it recursive? Does it include subdirectories? And the answer is yes. It doesn't typically include symbolic links because they can leave the directory and go to other places. So those are usually ignored, but it is recursive and includes subdirectories. Yeah. Other questions? Okay. Well, I'm happy to stick around for a little bit if people have more questions and want to come up and ask. Otherwise, I think we have our poster session now. So thank you everyone for coming. Please ask more questions and such in the Slack. I'm happy to answer. There's a lot to Docker, and it's a great tool, and it can take a long time to learn, but it's totally worth it. So I highly recommend spending the time.